Hi, this video is for anybody who's having troubles understanding one of the questions from Kognity. It states that it is observed that a particular emission spectrum contains three wavelengths originating from the transition between a first, second, and third levels in an atom. The longest and shortest wavelength are given to be 82.3 nanometers and 540 nanometers. What is the final wavelength, or what's the missing one? So we've got two of the longest and the shortest. So what's the final wavelength that you're trying to find? So to understand this, we have one of two possibilities here, which would be A or B. But in either case, the shortest wavelength is the one where the energy states are the closest together. So this right here would be one of the transitions between the shortest wavelength, or that could be closer to possibly the ground state, where this is the closest one together. So either way, there are two energy states that are fairly close together. That's the shortest. The one that's furthest then is, so this is the shortest, or this one down here is the shortest. And then the other possibility is that you have the longest, well, the longest is pretty much the same. Okay, so it's going to be the one from the ground state to the furthest one. Okay, so that hopefully is pretty obvious, longest. And so therefore the difference, what's left over, remember there's three possible energy changes here, right? It has to go from the first state to the second state. This is one possibility. This is the other possibility too, which means the only leftover possibility is the third one here, okay? So likewise, we have one energy transition here, two possible energy transitions, and therefore this one left over is the third one. So what that means is that gives us actually the difference between the two. So if there's a separation of 15 electron volts for the longest wavelength, I'm going to use one last color here. Let's try orange. So if the longest, no, I've used orange. Let's use blue. So the longest one was 15 electron volts applied to the longest one, and the one in between is 2.3, then what's left over here has to be the difference. Okay, so 15.1 minus 2.3 gives us 12.8. So what that's telling us essentially is this, the energy level here, so this here was 15.1. The one left over is 12.8. Okay, so that's how we understand that the last energy level, this drop from here to here, is 12.8. Okay, likewise, if this one up here was 15.1, and this shortest one created an energy change of 2.3, then the part that's missing is going to be 12.8 electron volts. So this is probably best understood with the diagram. Hopefully this helps explain things. See you guys next time.